Hello again, fourth graders, and welcome back to Math Workshop. Today's lesson is a combined lesson of 4.6 and 4.9, talking about the topic of partial product multiplication. I'm really excited to show this lesson to you, friends, because this is another strategy that you can pull out of your mathematician toolbox when you are asked to do multiplication, especially when you're asked to do multi-digit multiplication. So you remember that the last time we were together, we were talking about a different strategy, the strategy of partitioning or breaking apart rectangles. So we are going to utilize that understanding. We're going to really still think about that idea of partitioning. We're still going to use rectangles and partitions in today's lesson, but it's really as a jumping off point to show how we're going to start keeping track of the record keeping part of the partitioning. This lesson is really important because it's going to get you ready for the type of strategy that you can use also of United States traditional multiplication. So this is a really beneficial and helpful lesson, and it kind of breaks down those multi-digit problems into smaller pieces, and it shows us how to do the record keeping track of all the steps of the problem as we go. So as a quick review, you remember from the last time we were together that we learned how to do multiplication of multi-digit numbers using the strategy of partitioning rectangles. So that means taking our problem, which in this case is 660 times 5. So this is what the problem looked like to begin with, 660 times 5. So as we mentioned last time, we put the small number on the small side of the rectangle, and the big number we broke up into easier, more friendly numbers that were easier to work with. So we split 660 into its place value parts, 660. Obviously, we don't need a ones place because there are no ones. There are only 6 tens. So you remember from the last time, we broke this problem up into its parts, and then we would use what we know about the base problem. So in this case, it's 5 times 6. 5 times 6 is 30. And there are 2 extra zeros, so I'm going to add those 2 extra zeros in. The same exact problem is what we're going to do on this side. We're going to do the same thing. We're going to think about the base problem because this problem is 5 times 60. So we're going to use what we know about 5 times 6 is 30. And there's 1 extra zero there that we have to account for, so we would plug that in. So if we were doing partitioning of the rectangles, we would now do the addition part. We would say 3,000 plus 300, and we would get our answer of 3,300. So today I want to show you a different strategy using the same concept of place value, but this one is called partial product. So basically just what that means is that we're going to take each number, each digit in the multiplication problem, and we're going to think about how we can find the product just for that one individual digit. So here's what I mean. Since we've got 5 in the ones place, I'm going to just take my 5 and I'm going to do 3 separate addition problems. I'm going to multiply 5 times each of the place value spots. And over on the side, I'm going to record what those problems look like. And then I'm going to do addition. So this is what it looks like. 5 times 0, 0 is in the ones place, equals 0. Now I'm done with the 0. I can cross that out and forget about it. Now I'm going to take my 5, and this value is 5 because it's in the ones place. I'm going to multiply 5 times 60 because it's in the tens place. So even though the digit is 6, the value is 60. So my next problem is going to be called 5 times 60, which we know 5 times 6 is 30, and there's 1 more 0 to look at. The last problem that I have is 5 times 600. And I'm going to use what I know about my base digits. 5 times 6 is 30, and there are 2 more zeros. So now that I've done all of my multiplication all the way through all of the place value spots on my problem, now I'm going to do addition of all of these products that I found. And my answer is going to be, again, 3,300. So you can see that this strategy is a way of checking the partitioning of the rectangles. So it's really kind of the same idea, because when we partition rectangles, we were really concentrating on breaking these numbers up by place value spot. This is just the record keeping part. It shows us that we have to pay attention to every single digit in a multiplication problem, and we have to create a product for each one. And then when we get done with all the products, we can add them up and find the true product of the whole multiplication problem. Let's try another one. The next one I want to show you is this one down here, 20 times 34. So when we do the partitioning of the rectangles, your journal page is going to look like this today, where it's going to show you on one side how you can partition rectangles, and on the other side, it's going to ask you to try the partial product. So you really have to pay attention to the directions, because it's going to ask you to use one strategy or the other. So when we partitioned the rectangles, we did exactly that. We broke up this problem into smaller parts. 20 is a nice, even, friendly number, so that can go on the small side of the rectangle. And 34, it was easiest to break it into its place value parts. So when we do the partitioning of the rectangles, we're paying attention to place value. Let's try the partial product, and we'll come back and see if we get the same answer as our partition rectangle. So for partial product, I like to draw a line down the side of my multiplication problem where I can record keep. I can keep track of all of the individual problems I'm going to do, and I can be sure that I can do my addition problem when I'm done. So I'm going to walk my way through this problem, making sure that I pay attention to every single digit. So the first one I'm going to do, I always start on the ones place. That's what we do in math. So I'm going to start with 4, and I'm going to multiply it times the other ones place, 4 times 0. That's going to equal 0. Now I'm going to keep with the 4 because I'm not done with it yet. And I'm going to go, now that I've done 4 times 0, now I'm going to crisscross my way across, and I'm going to say, what is 4 times, not 2 because it's in the tens place, 4 times 20. That's my next problem. So I'm going to use what I know about base problems. 4 times 2 is 8, and there's 1 0. Now I'm all done with the 4. I have used the 4, and I've multiplied my way all the way through the problem. I'm done with the 4. I can pretend it's not there anymore. Now I'm going to move on to the 3, but it's not really a 3, is it, friends? Because it's in the tens place. So really, this is a value of 30. And if I multiply it times the ones place, that's like 30 times 0, which of course anything times 0 is always 0 itself. And I'm not done yet. So this time I'll do 30 times 20. So I'll use what I know. 3 times 2 is 6, and there are 2 zeros. So now that I've done both of the digits on the bottom, and I've worked my way through all of the place value spots, now I have an addition problem to do. I have 600. The zeros I'm just going to leave there because we don't need to include them. They're zeros. So my problem becomes 600 plus 80 equals 680. Now, if I want to check my work to make sure that I've got it done correctly, that's when I can go to my partitioning rectangles, and I can see if I get the same answer. So this is 20 times 30. We're going to use what we know about base problems. 2 times 3 is 6, and there are 1, 2 zeros. And 20 times 4, 2 times 4 is 8, and there's 1 0. So that means 600 plus 80 equals 680. So I can use my partitioning rectangles to check that I have gotten my answer correct in my partial product. So as you go forward today, you may see problems that get even bigger, right? They may be 3-digit by 3-digit or 4-digit by 4-digit. So the problems are most of the time going to look like this, where they're going to have the partitioned rectangle on one side of the page and the partial product on the other side of the page. Your job is to try partial product first and then go back and check with what you know about partitioning rectangles and see if you get the same answer to check your work. This is a really important skill because that strategy of working your way through place value spots and crisscrossing, that is the first ingredient that you'll need when we do traditional United States multiplication strategy. So you're going to find today's strategy is just another one in your toolbox that you can add to your knowledge bank and pull out whatever strategy works best for you. So this is a really important concept today. So I want to really make sure that you go slow, that you try the partial product first, and then check your work in the partitioning rectangles because both sections need to be completed. So really go slow and be sure that you check your answers when you're done. And if you're noticing, hey, I want to do a few more examples with you, Ms. Jungle, you know to send me an email so that we can get ourselves into a breakout room and work on some of these problems together before you go off to do your exit ticket. So really good luck trying this new strategy called partial product multiplication. Off you go, fourth graders.